Hello everyone, and welcome to this step-by-step introduction to the ANSYS CFX solver. This introduction will be broken down into 5 separate videos, one for each step. The aim of this introduction is to give you the basic knowledge required to run CFX simulations. The final goal is to visualize the wingtip vortex of a 3D wing with the help of the Q criterion. Feel free, don't hesitate to pause the video if I go too quickly. So, first things first, what you want to do is open an ANSYS workbench, and then here on the left, where all the modules that ANSYS has to offer, you want to double click on the Fluid Flow CFX. Now, this window should appear. On this window, we can see all the different steps we're going to go through. And now let's start with defining the geometry. So select the geometry icon, right click on it, and select New Design Modeler Geometry. So once the Design Modeler window is open, what we want to do is import the coordinate file of the profile we want to use. For this, just go to the Aerofoil Tools website and select whatever profile you want to use. So personally, I will take a 4412 NACA airfoil. And when you are on this window, make sure that the cosine spacing and the closed trailing edge options are selected. Then just click on Plot, and here you have the DAT file which holds all the coordinate points for the profile. Then what you want to do is open a blank Excel sheet and just copy all the coordinate points, all these values inside. Okay. Make sure, take special care to have the first 2 columns blank, because we are going to need them later on. Then what we want to do is go into the options here and make sure that the decimal delimiter is set on comma. Okay. Then what we want to do is separate the X and Y coordinate so that we have 2 separate columns. To do this, just follow my clicks. And here, what you want to do is set the decimal, switch the 2 delimiters so that it recognizes that there are decimals. So here we have. Now what we want to do is go to the line that holds the 0, 0 point, so the leading edge. And now what we want to do is we want to duplicate this line, so just add a new one and fill it with zeros. Then for the first column, we want to put ones everywhere, so just drag it all the way down. And then we want to enumerate the coordinate points for the upper side and for the lower side. So just enumerate them like this, and then for the lower line we do the same thing like this. Then what the final step that we have to do is just add the Z coordinate, which are just zeros all the way down. And now we are finished with the Excel sheet. Then what we want to do is create two text documents, so one for the upper line and one for the lower line. Then we just copy the 5 columns that represent the upper line, paste them in the text document, and do the exact same thing for the lower line. Very good. Now that we have our coordinate points, we want to go back to the design modeler window, and now just go into concept, 3D curve, and select the coordinate file you want to put in. So let's start with the upper line. Generate it, and here it is. Very good. And now do exactly the same thing for the lower line. So here just select in definition from coordinate file, and here the lower line. That's it. So now we can see that we have our profile, 2D profile, and now we want to go to create, extrude, and select both lines, apply. We want to add frozen here, and for the direction vector just select the XY plane, and it should give you the Z axis. Okay. Generate. So now we have our wing. What can be interesting is to maybe give the wing a little angle of attack, so that the Q criterion, the wingtip vortex, will be much higher and will be easier to visualize. Furthermore, if you select a symmetrical profile, you have to give an angle of attack to your profile in order to see the wingtip vortex. So to do this, it's very simple. You go to Create, Body Transformation, Rotate, select the wing. For the axis, you just go here and select Components. So it already is on the good axis, and now just give it -5 degrees. Very good. The next step is defining the fluid domain, where the meshing is going to take place, and the solving of the fluid mechanics equations. So to do this, we want to create a box surrounding the wing, and then cut out the wing from the box. To do this is very simple. Go into Create, Primitives, select Box, and now just enter the values I am going to show you. So of course, in the operation here, put add frozen, select add frozen. Very good. And now just generate. Now, in order to cut the wing out of the box, what we want to do is go into Create, Boolean, select the subtract for the operation. The target body should be the box, and the tool body should be the wing here. Very good. Generate. Now you can see that the wing has been cut out of the box. Then make sure that you only have one body. So the first profile we imported, we are just going to suppress it. Okay. Now for the last step, what we want to do is name every surface that we have, so that putting the boundary conditions, defining the boundary conditions will be a lot easier. For this, go into Tools, Name Selection, and now name the following surfaces. So this one should be the inlet. This is where the flow will enter the domain. Generate. Here we should have a symmetry plane. Create. Here, 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 and at the outlet, it's just gonna be openings. And last but not least, we have also to name the wing surfaces. So this one, and this one. Very good. Now we are ready to go on to the next step, which is the creation of the mesh. So stay tuned for the next episode.